Hello, MathSci here, and here is another example on how to solve and determine molecular geometries for this ion. So again, we're going to go through our steps that we did previously in the other video. So first of all, we have to find the number of valence electrons in Te, and Te has 6 valence electrons, and we add that with 5 times the number of fluorine valence electrons, which are 7 total, and then we add one more electron because there is a ion in this compound, and it is negative, and when there's a negative charge you add one, and if there was a plus charge you subtract 1. So the total valence electrons for this ion are 42 valence electrons, but if you want to find the pairs, you would just simply half the valence electrons, and that would equal 21 pairs. And with this 21 pairs, that will help us draw out our Lewis dot structure. So for step 2, we would draw the Lewis dot structure. So this is how you would draw the Lewis dot structure. So Te would be the central atom, and then you just draw your fluorines all around, fill the octet. And then also you have to include lone pairs because the element Te doesn't follow the octet rule, so you would have to leave out lone pairs. And don't forget to put brackets on this compound because it is an ion. So now, by looking at this Lewis structure, it will help us to determine the Vesper shape of the compound. But first, we would want to see the model in a molecule kit, and there are 6 electron groups. And if you just count all the atoms surrounding Te, so there are 1, 2, 3, 4, 5, and then 6. So that's how you would find what it looks like. See, again, we have lone pairs here, and then we have all the fluorines around the central atom, and that will help us to determine the Vesper shape again. So now that would be the next step, structure to draw the Vesper. Now in the previous problem, we said that to help us find the Vesper shape, we would have to find out how many electron groups are there. And by looking back at the number of electron groups, so what I would like to do, what I usually do is write 6 electron groups, and then I start drawing on what shape this the number of electron groups should look like. So you would simply just write a rectangle. Make sure it's a ruler. And write TE as your central atom. And then write the wedges. Draw the wedges. and then also this wedge too. Make sure you shade that in. And then you just write, and then do the fluorine. And then write all your fluorines. And don't forget the valence electrons surrounding the atom of both fluorine and TE. So that's how you would draw it, and then don't forget to write. Don't forget to do the brackets. So that would be a negative ion because it is an ion, and also the the angle of the Vesper is less than 90 degrees because of the lone pair right here. So, and also the reason why it repels is because lone pair, we also have to write this in, that lone pair and bonding pair repulsion is greater than bonding pair to bonding pair repulsion. And what that simply means is that the lone pair of this and the bonding pair that it surrounds is greater than the bonding pair of all the fluorines that are surrounding the central atom. So that's why we have to write this little statement in, so that will determine the relationship of the repulsion, and it describes the repulsion basically. So now we will look at the Vesper shape in this photo, and that's how it would look like. So the lone pairs are right here. The lone pair is right there, and the fluorines around the central atom are just, it's a repulsive action that it's undergoing because of this lone pair. So it's just going slightly up, and stuff like that, and that's how the Vesper shape would look like. The Vesper model, since it kind of looks like since it's like a square on the bottom, and you have a fluorine on the top, it looks more like a pyramid. So, and then our last step would be to name the molecular geometry, and by seeing the That's why we call this a square pyramidal. And that's how you determine the molecular geometry of this ion. If there's any questions you have, please leave a comment below, and I will answer them as much as I can, and I'll try to post more videos about determining the molecular geometry of compounds and ions. Thank you. This is MathSci here.